Alright, welcome again to the online lecture. This is the 13th week of this general physics and exercise, the second semester. Okay, so this week we will study chapter 36 and the title is diffraction. So this is going to be the continuation of what we have learned in the chapter 35. So there we study the wave properties of light, right? Okay, so diffraction is again a very important properties or wave properties of light. So try to make a connection between chapter 35 and 36. Then it will be not very difficult. Okay. Okay, let's make a review first. In the last chapter, we learned quite a few of things. We first learned the Huygens principle for waves. This Huygens principle was applied not just for light waves, but it is good for any waves. Okay, it's a very general phenomenon. And then using this Huygens principle, we learned the Snell's law of refraction, in which the angle of refraction was directly related to the index of refraction. Okay, and we also learned the law of reflection, which simply means that the reflection angle is equal to the incident angle. And by combining these two, we learned the total internal reflection. Okay, this total internal reflection is a very important phenomenon, so please make sure you understand it. And by using this Huygens principle, we also learned very important properties of waves, which is the diffraction and also the interference of these waves. Okay, interference simply a summation or subtraction between waves. Okay, and as a very simple example of this interference, we learned what happens when light waves go through a double slit. Okay, and then of course there will be diffraction and interference between these light waves. So therefore, as a result, we observe there's a repeating pattern of bright and dark areas. Okay, and then their position was directly related to the wavelengths of the light and also the distance between slits. Okay, and we also learned the interference phenomena of light waves from thin films. Okay, so in this chapter, we will continue what we learned in the chapter 35 and study diffractions and interference in a few different situations. Firstly, diffraction and interference from a single slit. So in the last chapter, we learned the case of double slit, but this diffraction and interference also appears when you have only one slit. Okay, and another thing, we will also learn the double slit just like in the last chapter, but now we will assume that each of these slits are wide. Okay, we will see what will happen in such a case. And we will also learn diffraction and interference from a grating. Grating is like many slits. Okay, so we will extend it to the case of many slits. And we will finally learn what happens in terms of diffraction and interference when lights go through an atomic crystal. Okay, for example here, this example shows you the DNA. And this diffraction and interference technique is data look like this, and this is how we find out where atoms are. Okay. All right, let's begin this chapter by reminding us that light is a wave. And in the last chapter, we learned that this diffraction, which is an important property of the waves, occurs when a light wave passes through a narrow slit, just like here. Okay. So, and then this is because of the Huygens principle, which means that every point on the wavefront creates its own spherical wavelet. Okay, so as a result, in the Young's double slit experiment, this wavelet was created on two narrow slits, and as a result, on the screen we observe this repeating pattern of bright and dark bands, right? Okay. But then we still have to remember that this diffraction occurs not just when it goes through narrow slit, but it can actually occur whenever a wave passes an edge. And we may also observe interference pattern in this case as a result. Okay, and we actually have already seen it in the case of Poisson spot. So in the last chapter, we actually have seen the same figure. So here the laser light goes on. into a small ball bearing. So when this ball bearing is blocking in front of the laser, upper and lower side of this bearing works as a rounded edge. So therefore the diffraction will occur from the upper edge and then the lower edge, and then the bright spot in the middle just here was simply the interference pattern due to the diffracted waves from the upper and lower edges. Okay, and also in this figure you can also see, okay, this is a knife blade, and then when you shine a light and then observe the pattern of the light on the screen, and there are spots, there are some shapes like this. Here you can see that there is a bright and dark and bright repeating patterns if you look at it closely, and this is exactly due to the diffraction of the edge of this knife blade. Okay, so this is actually the case, and so therefore what we are going to learn in this chapter based on this idea is that this diffraction pattern also appears in the case of single slit with wide opening. Because this single slit is very wide, this upper side and lower side of the slit works just like an edge, and as a result, when you create a spherical wavelet from this wide opening, it can create a pattern like this. This looks not exactly same as this, but you can still see the repeating pattern of bright and dark bands, right? Okay, so we'll try to study this in this chapter. Alright, before we study the single slit diffraction in theory, let's try to perform this simulated experiment just like before. Okay, so here we have a light source, and then now we have a slit. Okay, now this is a single slit. There is just one opening, right? But then this area of this opening is quite big. This is a wide slit. So therefore, this much area of this wavefront will go through this slit. Okay, so this must be different from the case of Young's double slit experiment, where a very narrow range of two wavefronts pass through. So therefore, now let's try to see what will happen when we observe the pattern on the screen. Okay. Alright, this is the experimental setup for single slit experiment. And in fact, okay, we don't have a slit yet, but here we have a light source, and let's turn it on. Okay. And the color of the light is now set up to be green, okay, which is probably the best in this setup. And this light source is creating a spherical wavefront. And on the screen, can you see any pattern? Okay. It's actually very difficult to see anything. It just looks bright, and it's because pretty much everywhere on the screen the light is falling at about the same intensity. So if we turn on the graph, it looks pretty much flat. Okay, right? And then now let's try to introduce the barrier which has one slit. Okay, now this much opening is a very wide slit. Okay, and then what is happening? Immediately you can see that this part is blocked, so therefore the light on the screen is very dark. But at the same time, you can see that still something is going on here. It may be a little bit difficult to see on your screen, but we can see that the light is actually diffracted this part. Okay, and on the intensity chart, as you can see, on the central part, the light is going up, so therefore this is the brightest at the center and pretty dark on the other side. Okay, so let me try to enhance the amplitude so that you can see it a little bit better. Alright, the intensity starts to increase and it's going even beyond the scale. Okay, can you see anything going on here? Interestingly, as you can see, okay, on this part, the light is going a little bit brighter here. So this is far away from the central position, so it actually has to be the effect of the diffraction. Okay, and at the same time, let me try to move the slit, and we can see something changing a little bit better. So I can also change the size of the slit this much, and let's see, let's wait a little bit. And as you can see, now this pattern on the screen and also the pattern on the graph looks different. Now here you can see somehow, of course, the central part is the brightest, but it is now not going down smoothly, but it looks like there is a small dip and then go up a little bit and then again dip again and then go up. So it's showing a little bit of wiggling. And on the other side, the same thing is happening. There is a dip here and then going up and then another dip and another dip. Okay, so this change of intensity, repetition between the bright, dark part is certainly the diffraction, which is a result of the single slit diffraction. Okay, so can you remember what it was like when we had a double slit? In fact, there we also had the repeating patterns of bright and dark spots, but the intensity was not going down when you move away from the central position. It was like going up, down, this much. But here, certainly the intensity is going down very quickly. So at when you move far away from the center, intensity becomes very dark. Okay, and the distance between the dark positions, or the distance between the central position and then the next bright position, is actually different from the case of the double slit interference, and we will see that in the next slide. Okay.